the videos. Okay, that's not an option. All right, so let's start here with degrees and radians. And I'm not going to repeat what was in the videos, but I need to have a running head start to get into that embedded question answer. So, so basically, last time before the test, I talked about radians and degrees are just two different ways of measuring angles, kind of like meters and yards, or miles and kilometers, depending on what country you're in. Okay, it's just two different ways of measuring distance. So degrees, there's more to it than that, okay, but that's the basic gist of it. Degrees and radians are two different ways to measure angles. And so I wanted to define what a radian is, because you're used to dealing with degrees. You're comfortable with degrees, all right? But you're not comfortable with radians because you haven't worked with radians before, probably. So I wanted to define exactly what a radian is. So what we've got here, and I've got a picture, if a radius is the same thing as a piece of circle, we call that arc length, okay? And so if my R value, hang on. I haven't been connected all weekend, so it doesn't remember itself, so hang on just a second. All right, so try this again. If my R value is the exact same distance or the exact same length as this piece of circle here, then what we have is that my central angle, now this is going to be really hard for you to understand. What's a central angle? It's the angle at the center. I know, isn't that difficult? Okay, so the angle at the center, we call that theta. That is a Greek letter. Okay, it kind of looks like that. Kind of looks like a zero with a niña going through the middle of it. And go a little thicker here. And we pronounce it theta. My central angle is equal to 1 radian. My central angle is equal to 1 radian. Okay, so that defines what a radian is. All right, so then let's head into the embedded question. If the central angle, or I'm defining again, the central angle measured in radians is going to equal arc length divided by radius. In geek speak, my central angle is the same thing as theta. My arc length is called L, and my radius is called R. We know that. Okay, so that's just basically those two statements are identical statements. One is in geek speak and one is in words. So here's the embedded question. Suppose a random circle's radius is equal to X units. What is that circle's circumference? So you kind of have to go backwards in your mind. What is the formula for circumference? 2 pi r, C equals 2 pi r. Okay, that's the generic formula for circumference. By the way, what does circumference mean? Yeah, it's the distance around. The distance around the whole entire circle. Well, what about this specific circle? Because it says that this circle's radius is equal to X units. So what is this circle's circumference? 2 pi times X. Okay. What is another word for the length of the arc around the whole circle? Circumference, you just told me that. That's the length of the arc around the whole entire circle. Okay. So then the radian measure of the whole entire circle, let's use that formula up there. Okay, so we're using this formula. I want the theta, the radian measure of the whole circle. So that's going to be the whole arc length. What's the whole arc length? It's 2 times pi times X. Divided by my radius. What's my radius? X. Oh, well, what can you do there mathematically? Cancel the x's, what's left? 2 pi. Now that actually shouldn't be such a shock, because didn't you memorize, without understanding, but didn't you memorize that if I go around the whole entire unit circle one time, you could go from 0 to 360 degrees, or you could go from 0 to 2 pi, right? So same concept there. All right, so that's what should have been then for the embedded question. By the way, well done on answering embedded questions. I grade those every test. All right, some of you got as much as 3 points added to your test because of embedded question bonus points. So well done on that. I also added bonus points for the practice test if you got an A, B, or C on the practice test. So well done, those of you who are keeping up with your work. Hey, if you don't like your grade on this test, let's start by doing the embedded questions, and let's start by working the practice test multiple times until you get an A, B, or C on it. It will make a huge difference, okay? All right, so let's go jump right into complementary and supplementary. All right, so if you have an angle that is 60 degrees, how do you find this angle's complement? Subtract it from 90, very good. And so if you subtract your angle from 90, what do you get? 30 degrees. How do you find that angle's supplement? Subtract it from 180 and you would get 120. Okay, because complementary angles have to, their sum has to be 90 or pi over 2. Supplementary, their sum has to be 180 or pi. All right, so then let's go to example number 2. I'm going to show you how to do this 2 different ways. All right, how would I find the complement of this angle? How did you find the complement of the first example? Yeah, so instead of subtracting from 90, you're going to subtract from pi over 2, okay? So we're going to have pi over 2 minus pi over 3. Now, guys, you know how to add and subtract fractions. Yes, you can use your calculator if you need to. By the way, if you need to use your calculator, don't put the pi in there, just do 1/2 minus 1/3, okay? Or you can just simply use common denominators and think about the fact that 3 pi over 6 minus 2 pi over 6 is equal to 1 pi over 6. Now, can you pull out your unit circle? I see most of you have your unit circle out. If you don't have your unit circle out, it should be out. Probably just about every single day from here on out. So pull your unit circle out. And I want you to focus on the spokes, okay? Look in just the first quadrant. Okay, or maybe you could call them spokes, or you could even call them pi pieces. How many pi pieces do I have drawn in the first quadrant? There's 3 pi pieces. You see those? Okay. And what is each pi piece equal to in radians? Pi over 6. Each one of them is worth pi over 6. Remember in the video I taught you that you would be counting all of your spokes by pi over 6s. Okay, so you'd have 1 pi over 6, 2 pi over 6, 3 pi over 6 for the first quadrant. Okay, now can you focus on pi over 3? You see it? Now the complement just says you got to get up to the top, right? Pi over 2 or 90 degrees. So then how many more pi pieces do you have to go through if you're sitting on pi over 3 to get to pi over 2? You got to go through 1 pi piece. And what is 1 pi piece worth? Pi over 6. So this is a second way to look at this exact same question without adding and subtracting fractions. Okay, now let's use the unit circle method to get the supplements. So for complement, we had to get to the top of the circle. Where do we have to get for the supplement? Yeah, we got to get all the way over to pi, the left side of the circle. Okay, if you're sitting on pi over 3, how many more pi pieces do you have to go through to get to pi? 4 more pi pieces. And what's 1 pi piece worth? 1/6. So we would say that this is 4 pi over 6's, right? Except that we're never going to leave it like that because that's an unsimplified fraction. So what is our fraction simplified? 2 pi over 3. If you had done this mathematically, let me just come over here really quickly, you would have said pi, subtracting pi over 3. You would have gotten a common denominator, so you would have said that pi is 3/3. So 3/3 minus 1/3 is 2/3. Same thing, okay? I don't really care which method you're more comfortable with. If you're more comfortable with adding and subtracting fractions, that's fine. If you're more comfortable with the picture, that's fine. Okay, it doesn't matter to me as long as you can explain what you're doing. All right, one more example. So what about if we have an angle that measures x radians? So you need to think about the math that you did for example 2. How do I get the complement? Can you say it again? A little louder this time? Pi over 2 what? Yep, pi over 2 minus x. Now, how come we don't do 90 minus x? Oh, because it's in radians. What about for the supplements? Pi minus x. All right, find the complementary angles that are 9z plus 6 degrees and 3z degrees. Okay, so what do you know about complementary angles? I hear lots of muttering. I just can't understand because of the face masks. Good, they add up to 90. They add up to 90. So I'm going to take my two angles and I'm going to add them together. And when I add them together, they're going to equal 90. That's just following the definition. So my first angle, 9z plus 6. My second angle, 3z. So there I'm adding my angles together. And when I add them, they equal 90. And now it's nothing more than Math 101 junk, right? Combine like terms. You got 12z equals what, 84? So what does z equal? 7. You finished? Go back and read the directions. What does it say? Yeah, it says find the complementary angles. We haven't found any angles yet. All we did was find the value of z. So how am I going to find my angles? Yeah, plug and chug. Now, would you rather plug the 7 into the first angle or the second angle? Second one's easier. Okay, so 3 times 7 is 21 degrees. So one of my angles is 21 degrees. What's one way you can get the other angle? Yeah, subtract 21 from 90. What's a second method that you could use to get your other angle? Plug it back into that 9z plus 6, whichever one you're more comfortable with. I think subtracting is a little easier. So what's 90 minus 21? 69. Is it warm in here? I think I'm gonna die. Let's see if that works. All right. In the picture for number 5, what do you notice about these two angles? They are, say it again? They are supplementary. If your brain said they equal 180, they do not equal 180. Because when you say that, you're actually telling me that each angle equals 180, and that's not true. Okay, the sum of those two angles is 180. All right, so you guys go ahead and find this one. Check it with somebody close by, see if you got the same thing. All right, did you get an X value of 10? Okay, but that doesn't give you your angles. Okay, so I'm gonna plug mine into the first one because that'll give me 100 plus 7, which is 107 degrees. And so the second one is what? 73. All right, no big deal there. Okay, so you're gonna need your calculators out, so go ahead and pull those out. Did I include this video link in my lab for the calculator? Good, because it's not mine, right? I didn't make that video, it was somebody else. Yeah. Gave you a break from listening to my voice over the weekend. Okay, so then what I want you to do, because I'm not going to teach it to you since I've already provided a video for you, I want you to teach me. Okay, so this is I believe, goodness, this link is so old I can't even remember what's on it. I believe that it went both directions. So look at number 6, convert to decimal degrees, round to the nearest thousandth. Okay, so tell me, how do I do this in my calculator? What do I do first? Okay, so you type in 34. Good. And then what? Second angle. Okay. And go to the degree symbol. And it bumps you back to the home screen. So now your screen says 34 degrees. All right, somebody else, what's next? Because you don't do anything with that yet. According to the video, what do you do next? Juan did a good job. Who's going to step in for him? Mayona, what do you think? Good, type in 51, and then what's after that, Mayona? Very good. Second angle and go to the, what, by the way, what is that symbol? I know it's an apostrophe in English, but what is that symbol in math? It's minutes. It's minutes. Very good. All right. Jaden, what's next? Good. Yeah, so this one was a little different, right? It wasn't in your angle menu. You couldn't just go to second angle. So you did 35, alpha, it's the plus symbol, right? Alpha plus? Okay, so alpha plus, and that's where your little double apostrophe is. Now, but what's that the symbol for? Seconds, okay? Then what? This is the hard part. Push enter. Okay, now I don't know what's in the calculator. I didn't even bring my notes with me today, but I can look at number 6 and I can tell you for sure it's 34 point something. I don't need a calculator to tell me what the whole part of the degree is. It's 34 whole degrees plus a little more, okay? But I do need your help with the decimal part. And this says that we should be rounding to the nearest thousandth. So somebody read me the numbers all the way to the 10,000th place. 34 points. 8597, did I hear you correctly? Okay, now how are we gonna round that to the nearest thousandth then? 860. Is there a symbol here? Degrees. Folks, these are both in degrees. It's not like I'm going from degrees to radians. These are both different types of degrees. It's kind of like saying, okay, look at the clock back there. You see how it's almost 11:30? Okay, almost 11:30. Would you agree with me that that's the same thing as 11 hours and 30 minutes into the day? That's the same thing, right? Me saying 11:30. Would you agree with me by saying that is 11 and a half hours into the day? Yeah? Is that the same thing as saying 11.5 hours into the day? Yes. So if 11.5 hours is the same thing as 11 hours and 30 minutes, that's what this concept is. So I'm going from one type of degree to another type of degree. Okay, they're both degrees. They're just separated differently. Okay, one in decimals. Which one do you think is the more accurate version? The DMS, degrees, minutes, and seconds, or the decimal degrees? DMS is the more accurate. Okay, all right. So then let's go the other direction. In the same way, I don't have my calculator out, so I'm not doing this work. But if it says 102 point something, 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 I already know that my answer is going to be 102 degrees something. Because it's 102 whole degrees plus a little bit more. Okay? So you teach me from the video, how do I take 102.3771 and turn it into DMS? What am I typing in? Bethany, what do you think?
Type in 102.3771, second angle, and then the fourth one, which is DMS.
Yeah, the fourth one says turn it into DMS. Okay. All right, so then go ahead and do that. Push enter. And then this one says that we should round to the nearest second. Can you guys read me what the second says on your screen right now? 37.56. Okay. So so what is my number of minutes on this one? 102 degrees. Say it again. 32, 22 minutes, and you said 37.56 seconds, right? How are we gonna write this correctly according to the directions? 38 seconds. Okay. Coterminal angles, two angles that land in the same spot. That's basically what the deal is here. So let's look at number 8. Question number 8. Sketch an angle in standard position. Okay, this goes all the way back to the very beginning of the video. The very beginning of the first video. First page of notes. What is an angle in standard position? What does that mean? Zaccharia, what's one thing that has to be true in an angle in standard position according to the video? Good. You have to have one ray that's on the positive x-axis. Okay. What's that guy called? The initial side. Okay, the initial side. All right. What's the other side called? The terminal side, because that's where it stops. Right? Okay, so this says that we should sketch an angle in standard position. So that automatically means that I'm going to be sketching an angle. Come on, straighten out. What are you doing? There we go. Use a different color here. All right, so I'm automatically starting out on the positive x-axis. Now, approximately where is 89 degrees? If I'm going to start rotating my initial side, where should I stop? Right before 90? I mean, I'm not going to ask you to get out, you know, your protractors or anything. But maybe it kind of looks like this. Now, that's my angle in standard position, but I haven't shown the direction of rotation. Why does that matter? What does the direction of rotation tell me according to the video?
Positive or negative?
Yeah, it tells me if it's going to be positive or negative. Since this is a positive 89, which way do I have to go? Counterclockwise? So we're going to show my angle, show my direction of rotation. Now this says that we should find two more angles, one negative and one positive, that are coterminal, literally terminating at the same spot. Okay, so the easy one is probably the negative one. All right, so let's go back to the initial side. And this time, instead of going in a positive direction up to 89 degrees, let's go to the initial side and let's go in a negative direction all the way around and stop in the same place. The question is, what's the value of that angle? Okay, so if I start at my initial side and I go in a negative direction just to the bottom, how far have I gone? Negative 90, and then if I go back up to the x-axis, how far have I gone now? Negative 180, and then if I continue to the next axis, how far have I now gone? Negative 270. Now I need to keep on going until I stop on my first terminal angle. So how far will I have gone? Negative 271. So negative 271, that angle is coterminal with 89 degrees. It stops in the same place. Okay. Now, it also asked me for a positive one. By the way, this isn't the only answer. Negative 271 is not the only negative answer, right? Because, can you take a look up here? Yes, it was negative 271 to just get to it the first time, but what if I went around again? And what if I went around again? And again, and again, and everybody in here could have a negative angle that was correct, but different. Okay, as long as they just went around whole circles after that. So that's a clue. So how do I get to 89 degrees, to that spot, by going in a positive direction? How do I get back there? All the way around, right? So if I go all the way around the circle, how far is it if I've just gone once? 360, and then another 89 degrees lands me on top of that same terminal ray. All right, so where am I now? Aaliyah says 449. Do you agree with her? Now, I never said that these angles were all equal to each other. I just said they're coterminal. They all stop in the same place. If I drew all three of those angles, they would look exactly the same. The only thing that would look different is the direction of rotation. Okay. All right. Next, number 9. Sorry about that. 10 and 11 kind of got squished together, but we'll get there. Number 9, find the angle of least positive measure that's coterminal to the given angle. Least positive measure, here's the English version of that. Whatever's on your normal unit circle. That's least positive, right? So anything between 0 and 360, or anything between 0 and 2 pi is going to be the least positive measure. All right? So when we're looking at negative 98 degrees, think first of all, where is negative 98 degrees? Which quadrant? third. Because I'm going to go in the negative direction, 98 degrees. Okay, so that's negative 98 degrees. But I asked for a positive angle that's coterminal to that guy. Okay, so what is that spot on the regular unit circle? Now, it's not one of your memorized values. But if I were to go, let's see, let me go ahead and draw an angle. If I were to go this direction, where would that same angle be? Tell me, first of all, how you're going to get that. Don't just give me a final answer. How do you get that? Subtract, from? Yeah, subtract from 360. So if you do 360 minus 98, what do you get? Are you saying 262? Let me show my work here. That was 360 minus 98. All right. Example number 10 is 539 degrees. 539 degrees. So the first thing, where is that? How do I find 539 degrees? Yeah, well, I know if I go all the way around one time, that's 360. So how much past 360 is 539? Say it again. 179? Okay, so this is going to be 539 is all the way around once and then around again all the way up to 179. Okay. So then what's the angle coterminal to that? And really, you've already given it to me. 179, yeah. So you did 539 minus a whole circle, 360, and you got 179. Example number 11 is negative pi over 3. So take a look at your unit circle. You can describe this maybe in pi pieces or with spokes. Where is negative pi over 3? Two pieces where? How do I get there? Clockwise or counterclockwise? Clockwise, two pieces, because it's negative. Because it's negative. The regular pi over 3 is counterclockwise, two pieces. Okay, so we're going to go roughly around here. All right, now what is the angle that is coterminal to negative pi over 3? You're looking at your unit circle. This shouldn't be very difficult. 5 pi over 3. Now, that's easy when you're looking at the unit circle. But what would we do if all I had to depend on was math? For instance, what would I do if that example number 11 had said negative pi over 8? And you don't have any pi over 8s on your unit circle. So what kind of math would you do to be able to figure that out without the 8 of the unit circle? 2 pi. Yeah, it was 2 pi minus pi over 3. Okay, so that's the math that you would do. As long as it's on the unit circle, it's easier to use the unit circle, in my opinion. All right, but if it's not on the unit circle, a pi over 8, a pi over 5, a pi over 12, a pi over 7, something ugly, then you'll have to use some math for that. All right, degrees to radians and vice versa. In order to go from degrees to radians, you have to think about the video here the part of the video that talked about the fraction 180 over pi or the fraction pi over 180. Do you remember from junior high? I'm going to just kind of come to some scratch paper over here. Do you remember math questions that involved you to convert units? So for example, what if I said convert 60 miles per hour into feet per second? Do you remember these kinds of questions? What? Yeah, we do. They weren't that bad. Okay, tedious, but not that bad. How did we set those up? Do you remember? Okay, so 60 miles over 1 hour. And what would we start multiplying by? Okay, so, and it doesn't matter what you worked with, whether you worked with the time first or whether you worked with the distance first, it didn't matter. So let's go with time, okay? So what was the goal? What do you want, what label do you want to go away? That miles and the hours, and what label do you want remaining? The feet and the seconds. So if I'm dealing with time, what was I gonna multiply by? 1 hour over 60 minutes. All right, now let me stop right here. Why did I use 1 hour on top instead of on bottom? Oh, I wanted my hours to cancel out, right? I wanted my hours to go away. Why did I use 1 hour, or why did you use 1 hour over 60 minutes? Why not use 1 hour over 60 seconds? What had to be true about the top and the bottom? They must be equal. Now, wait a second. If you have a fraction and the top and the bottom are equal, what do you know is true about that fraction? It equals the number 1. What happens when you multiply by the number 1? Nothing happens. You get the same thing back, right? That's why it's legal. That's why we multiply by the number 1, because I'm not changing anything. I might be changing the looks of it, but I'm not changing the value of it. And that's exactly what we're going to do to change from degrees to radians and from radians to degrees. I know that 180 degrees over pi radians, that has to equal 1 because the top and the bottom are equal values. And when the fraction is the same on top and bottom, it equals 1. So let's use the conversions again. This time, it says convert from degrees to radians. What label do I want to go away? Degrees. What label do I want to remain? Radians. So when I go and I multiply by my fraction, am I going to choose the fraction that has 180 degrees on top and pi on bottom, or am I going to choose the fraction that has the pi on top and the 180 on bottom? Why do we want the pi on top? We want those degrees to cancel. Now, you could type this into your calculator, but unfortunately, it would give you the wrong answer. And the reason is because of the rest of the directions. It says that we should leave as rational multiples of pi. And said, oh my word, that is so mathy. Rational, leave it as a fraction. Multiple of pi, leave pi in the answer. Okay, so that's all that means, is leave it as a fraction that has pi in it. Okay, so if you don't like to reduce 165 and 180, that you can do in your calculator. So go ahead, type in 165, divide 180. Do you guys know how to turn into fractions? Math, frac. So when you get 165 divided by 180, math, frac, what do you get? Say it again, 11/12. Okay, so then don't forget your pi, it's still in there. 11 pi over 12. Now, the cool thing about radians is that the lack of a label automatically says it's a radian. So do you see how I didn't write 11 pi over 12 radians? I wrote no label. No label automatically means radians. Okay, so I don't have to write radians. I do have to write degrees, but I don't have to write radians. Okay, what about number 13? So what am I going to multiply? What fraction will I multiply by? Thank you. Thank you for someone paying attention to me. I appreciate that, Yamin. All right, and then I'm going to do my reducing here. Hopefully you don't need your calculator to reduce 3/18. Okay, 3/18 is just 1/6. So this is gonna be pi over 6. Did I forget something? The negative. By the way, this one, you could have just looked at your unit circle, right? Where is 30 degrees the same place as? 5 or 6. Yeah, so I didn't actually have to go through all that work. Okay, that one was an easy one. All right, now let's go backwards. Convert from radians to degrees. What's the label on this one? Radians. How do you know it? Because there's no label. All right, so what are we going to multiply by then? Yeah, why are you choosing the 180 over pi version? No, it's not canceling out the pi. That's a big deal. What is it? What is it that we need to cancel? The radians. That's the big deal. That's the big deal. And you'll see that it's a big deal in a example I do in just a couple minutes. Okay, now the pi's do cancel here. And I like to reduce, so 180 divided by 3 is the same thing as 60, and then 2 times 60 on top is 120 degrees. By the way, this is another one of those that you could have looked at your unit circle. You could have gone to the 2 pi over 3 spot and seen that this is the same as 120 degrees. I'm not always going to choose something that simple, though. For instance, your unit circle doesn't have 15 pi over 4 on it. Okay, so that's not an option here. So what are we going to multiply by? 180 over pi. Why did we choose this fraction? What's canceling? The radians are canceling. Okay. Oh, let's see. 4 goes into 18 4 times with 2 left over. So that's 45. I don't know what 45 times 15 is in my head. Help me out. I can't understand you. 675. Thank you. It's the masks. It's the masks. That and coupled with the fact that old people start getting deaf. So both of those. Okay. Let's look at number 16. Can you tell me, how does number 16, how is it different from numbers 12 and 13? Because both of them are going from degrees to radians, right? Okay, so yeah, number 16 has at least DM anyway. What else is different? Yes, can you say that louder? You're rounding. You're rounding. So for number 16, you're required to round, but for number 12 and 13, you are required to leave that as a fraction, no rounding. Okay, so that's a big deal. By the way, I'm big on whether or not you follow the directions on rounding versus not rounding. Okay, so for number 16, what's the math that we're going to do? The first part of the math is identical to what we did in examples 12 and 13. What label is it that we need to go away? The degrees. So then what fraction will I be multiplying by? Yeah, the pi over 180. Okay. Now, there's really not any work to show here because the rest of what you do is going to be done in the calculator. So you're going to type in 174 degrees, 50 minutes times pi divide 180. So don't put the degree on 180 because you didn't put a radian on the pi. So neither of you should carry it. Also, why are you doing? Don't put the degree on 180. Don't put the degree on 180. So you should be typing in, did you type in 174 degrees, 50 minutes? You're confused on doing what? That part of it? Okay, ask one, we'll show you. Jaden, you figure out what you were doing wrong? You guys did the same thing? Can I see it again? All right, so what do you guys have rounded to the nearest hundredth? 3.05. Okay, and again, that's in radians, but I don't have to put a label for radians. Okay. I was gonna say something. Hang on. Dylan, were you able to get those degrees and minutes typed in? Okay. I don't remember. I was gonna say something and now I don't remember what it was. Oh, okay. So a lot of you put a degree symbol on the 180. The pi and the 180, it doesn't require symbols on either one of those. Okay, not in your calculator. It's weird. Sometimes when you put the degree symbol in, it'll be correct, and then sometimes it won't be correct. It's kind of funky. I haven't figured out the rhyme and the reason to that. All right, let's look at 17. What are we gonna multiply by? 180 over pi. How come? Yeah, I want my radians to disappear. Do you remember how a few minutes ago, when you guys said, I want to multiply by 180 over pi because I want my pi's to cancel? That's not the case here. It's a radian, but it doesn't show the pi ends. Okay, so we can't depend on wanting pi's to cancel. We need to depend on what label to cancel, degrees or radians. So this case, we want our radians to cancel. So go ahead and you're going to multiply by 180 over pi. This is definitely a calculator question. And then with the rest of the directions, what are you gonna do? Yeah, you need DMS. How do you get there again? Yeah, second angle number 4. So I want you to go ahead and use the directions and write down what you think the answer is. After you write down what you think the answer is, show it to a person nearby and see if they agree with you. Write down your answer with the rounding and everything and show that. Don't just show your calculator screen to the other person. Show what you wrote down. Hey, 16 people. I did not see one correct answer. Not one. Okay, so think through it. What's the problem? What? Okay, so go ahead, explain it loudly.
So, it'd be 35 because there's 60 seconds in a minute. So, 40.684 is greater than half.
Yeah. Yeah, did you guys understand what she was talking about? How many seconds does it say there were? It was 40-some seconds, right? Now, 40 is more than halfway because there's a total of 60 seconds. So if it's past the halfway point, what does that do to the number of minutes? Yeah, you gotta round up. So that's gotta be 35 minutes, not 34 minutes. Does that make sense? Okay. Can I direct you back to a question that we did just a couple of minutes ago? My brain said, come back to this. Aha, number 7. If I had said round to the nearest minute on number 7, what would my answer have been? 23 degrees because it's more than 30 out of 60 seconds. Okay? And I didn't say it there knowing that we were going to come into this and I was going to set you up to make a mistake. But now you're probably really going to remember it's going to stick, right? So it does even more than me just telling you. Okay, so I wasn't paying attention to the whole entire answer. What was the number of degrees? 19 degrees? Speak up. And 35, right, minutes? Very good. Okay. A small note here is that for your videos for section 9.2, you should be thinking 6 answers, not 4. And sometimes students walk away from that video and they say, I thought you only wanted 4. I don't, I want 6. Okay, so just kind of keep that in mind as you go and work through that. Okay, so what I want to do, I've got a bit of extra time, which doesn't always happen. I want to, there's 2 things that I would like for us to work on. You have a choice. You can either work on some section 9.1 homework, okay, and I will walk around and help you. Or if you have a question about your test and something that you got wrong on your test, this would be a prime time where you don't have to text me or email me. You've got me right here with you that I can answer that question. Okay, so that's your choice. If you don't have any test questions, then just go ahead and pull up homework. If you do have some test questions, or if you haven't had a chance to review your tests, now would be a good time to do that.